Let us talk about some gas laws. So gas laws are formulas that help us predict how gas molecules behave if you change the following variables. Let's say you wanted to change the pressure. What would happen to the volume? Let's say you wanted to change the volume, or the temperature, or the number of moles. So this stands for pressure, volume, temperature, and moles. Okay, remember that the temperature always have to be in Kelvin. Okay, so the first gas law is called Bohles Law. If you look at this picture right here, you have a syringe that's pressurizing or pushing the gas molecules inside it, and it has a very low volume. So at a low volume, they're squeezed together and the pressure is very high inside the syringe. If you make it bigger, expand it, then it's not so much pressure. Inside, they have a lot of room, so there is low pressure. So what Boyle's law states is that if volume gets bigger, as you can see here, it used to be a small volume and then the volume gets bigger, what happens to the pressure inside? Well, the pressure inside goes down. Okay? If one goes up, the other goes down, what kind of relationship is that? Yes, it is called an inverse relationship. Okay? And the relationship, and the formula goes like this. P1V1 is equal to P2V2. Okay, so what does this mean? Once means in the beginning and two means in the end. If you, like you see here, you doubled the volume. If you double this number, you're going to have to cut the pressure in half to account for what you've done. Okay, so more on that later. We will practice a lot of problems for that. So the formula also states that if one goes up, the other has to go down to equalize the other side. Okay, if this one goes up, then this has to go down. Okay, Charles' law. Charles' law talks about the relationship between temperature and pressure. Okay, so as you can see in this picture, what happens to the flame? Okay, so it gets bigger. So here's, it's very hot. I'm sorry, not temperature and pressure, temperature and volume. Okay, so as you increase the temperature, then the molecules will expand if this is a movable piston, and the volume will be bigger. Okay, so you have to do this in a movable container. So if you have a balloon and it's very cold, the molecules inside it are sealed and it can't come out. If you take that to a hot room, what's going to happen is the molecules will gain enough kinetic energy and push the balloon to get bigger. Okay, so the volume increase. As temperature goes up, the volume goes up. Okay, and this is a direct relationship. Okay, so the formula goes like this. T1V1 is equal to T2V2. Or you can also do V1 over T1 is equal to V2 over T2. It doesn't matter which one goes on the numerator or denominator, because if you double the V, you will also double the temperature. Okay, so this is what you would normally see in the book, right? The next one is called Bohles Law. Okay, this one tells us the relationship between the temperature and the pressure. Okay, in this case, as different from this one, this piston is movable, it moves. So you can change the volume. Here, this piston cannot move. Okay, so if you heat it up, you're going to give these molecules enough kinetic energy so it'll hit the sides of the container more often, and the pressure goes up. So as temperature goes up, the pressure goes up. This is also a direct relationship. So can you guess what the formula would look like? Would it look like Bohles Law or Charles' Law? You're right. This is direct. This is also direct, so it would look like Charles' Law. Okay, so it would be P1 T1 equals to P2 T2. If you double the temperature, you'll also double the pressure. Okay, the next one is Avogadros Law. As you can see, Avogadro talks about the number of moles. The symbol for moles is lowercase n. Okay, so if you have 1 mole, and this is a movable piston right here, if you have 1 mole and you add more in there, that means you're going to double the volume. So if the number of moles go up, then of course the container will go up. The volume in the container goes up. It might be better to show you in a balloon. So in a balloon, if you had 1 mole in there, it'll be a certain size, let's say 1 liter. If you add 2 moles in there, let's say you blow more moles in there, then of course you're going to double the volume. 2 moles, 2 liters. Okay, this is also a direct relationship, which means it'll look like the formulas like these. So it'll be V1 over N1 is equal to V2 over N2. If you double the volume, if you double the moles, you double the volume, and vice versa. Okay, so the combined gas law combines the pressure and the volume. So it looks like pressure and volume here, P1, V1. And then it puts the N in the denominator. So it's combining these formulas together. So it's P1, V1, I'm sorry, not the N, the T. So the T's in the bottom. So P1, V1, T1 is equal to P2, V2, T2. Okay, as you can see, P and V are inversely related. If P goes up, V goes down. While P and T are direct. If P goes up, T goes up. If V goes up, T goes up. That's why that's the relationship. So the difference between the other laws and the combined gas law is that you can have 3 variables changing at the same time, while these, you're only changing 2 variables at the same time, keeping the rest of them constant.